Hello grade 10s and welcome back to another video. In this video, we will go through the rules that we use to name and write down the formulae of different covalent compounds. In order for you to make the most out of this video, it is very important that you understand what a covalent bond is. We say a covalent bond is the sharing of electrons between atoms to form molecules. Now we get different types of atoms. We have metal atoms, non-metals, and semi-metals, better known as metalloids. Covalent bonds take place specifically when non-metals bond to non-metals, and there are electrons that are shared between these non-metal atoms. The fact that it is non-metal bonded to non-metal is very important for this video. Now, some substances have been known to us as humans for a very long time, and they therefore have common names that we often use instead of their correct chemical names. These substances include substances like water, sulfuric acid, ethane, nitric acid, hydrochloric acid, methane, and ammonia. The chemical name of water would be dihydrogen monoxide. If we look at hydrochloric acid, its name should be hydrogen chloride. Ammonia we should refer to as nitrogen trihydride, and sulfuric acid we would better call hydrogen sulfate. But since we have known these substances for a very long time, we often make use of the common names instead of the chemical names. And it is very important that you familiarize yourself with these names. Now, of course, in order to name chemical substances correctly, there's a list of rules that we will need to follow. And displayed to your screen, we have the list of rules that we use to name covalent substances, or in other words, substances that only contain non-metals. Firstly, we say, when the substance only contains two elements, then the name ends with "ide." The element that is leftmost on the periodic table is normally named first. The prefixes describe the ratio in which the elements combine. We have prefixes like mono, which refers to 1, di, which refers to 2, tri refers to 3, and tetra, which refers to 4. The list does go on, but in this video, you will see a maximum of 4 atoms, or 4 of an element, a type of atom, in the compounds. What is very important is that mono, or the prefix mono, is only used when describing the second element that we name. It is not used for the first element. So in order to make sense of this, we have a few examples of questions that you may be asked. The first question says, name the following covalent compounds. Now the first question we should ask ourselves is, how do we know that these are covalent compounds? The first compound only contains carbon and oxygen. Both of these are non-metal atoms. We then have a compound that contains nitrogen and oxygen. Nitrogen is also a non-metal atom. The next one contains phosphorus, the next sulfur. We then have silicon, phosphorus, and bromine, all of which are non-metals. So all of these compounds contain only non-metal atoms and are therefore covalent compounds. And that means that this list of rules applies to these compounds. So when we look at the first compound, it contains carbon and oxygen. Fortunately, the second rule is used when we name the compounds, but it is also used when we write down the chemical formulae. So that means we should write down the name of carbon first, because carbon is actually leftmost on your periodic table when we compare carbon and oxygen. This substance only contains one carbon atom. But remember, we do not use the prefix mono for the first element, so we just write down carbon. For oxygen, we write down mono, and this is oxygen. But the name must end with "ide", so it becomes oxide. So this is carbon monoxide. We then have nitrogen, but there are 2 nitrogen atoms in this compound, so we therefore start off with the prefix di. It is dinitrogen with no space between the prefix and the element name, And since we have one oxygen atom, we once again have monoxide. So monoxide, like this. Then we have 2 phosphorus atoms that are bonded to 3 oxygen atoms. Phosphorus will get a di, so it is diphosphorus. And the oxygen now gets a tri instead of mono, so it is trioxide. The name still ends with "ide" because this compound contains only 2 elements, specifically phosphorus and oxygen. It does not contain 2 atoms, but 2 elements. We then have a substance that contains sulfur. Sulfur is leftmost, so we write down sulfur first. It does not have a prefix because it is the first element that we're going to name, and there's only one of them, of course. Then oxygen will become trioxide because this compound contains 3 oxygen atoms. We then have silicon, and it will be dioxide because this compound contains 2 oxygen atoms. The last compound does not contain any oxygen at all. It contains phosphorus and bromine. The phosphorus, we have 2 phosphorus atoms, so we use diphosphorus. And since we have 4 bromine atoms, we're going to make use of the prefix tetra. And this is therefore tetrabromide, where the name ends with "ide" because once again, this substance only contains 2 elements. So notice that the prefixes di, tri, and tetra can be used on the first element. Over here we have dinitrogen, diphosphorus, diphosphorus again. But we do not use the prefix mono for any of the first elements. We only use it for the second element. The instructions for the last examples in this video say, write down the chemical formula of each of the following compounds. The first one is nitrogen trichloride. We have no prefix on the nitrogen, so we know that this substance is going to be N. Chloride refers to chlorine atom, so we write down Cl. Tri tells us that this molecule contains 3 chlorine atoms, so we use the subscript 3 in order to refer to the 3 chlorine atoms. Then we have boron carbide. There is no prefix on any of these element names, and therefore this is just Bc. Then we have dinitrogen trioxide. The di on the nitrogen tells us that the molecule contains 2 nitrogen atoms, so we use the subscript 2 to refer to those 2 nitrogen atoms. Oxide refers to oxygen, and the tri refers to 3 of these oxygen atoms. So the subscript only refers to that element symbol that it is on. Then we have sulfur dibromide. Since there is no prefix on the sulfur, it means that we just write down S, or that there is only one sulfur atom in this molecule, so we write down S. Dibromide refers to bromine atoms, and there are 2 of them. We then have nitrogen monoxide. Again, there is no subscript on the first element name, so this substance only contains 1 nitrogen atom. And mono on the oxygen, on the oxide, tells us that there is only 1 oxygen atom. The very last compound is phosphorus trihydride. Phosphorus has the symbol P, and trihydride refers to hydrogen atoms. Specifically, we have 3 hydrogen atoms in this molecule. This brings us to the end of this video on naming and writing down the chemical formulae of covalent compounds. In the next video, we're going to take a look at how we can do the same thing, but instead for ionic compounds.